Greetings. My name is Charles Vardeman, and I am faculty in the Center for Research Computing at the University of Notre Dame. I'm also part of CI Compass, and so CI Compass is an NSF-funded cyber infrastructure center of excellence, which is aimed at the data life cycles in major and mid-scale facilities funded by the NSF. And so we sort of provide a place for major and mid-scale facilities to go to talk about cyber infrastructure, about the data lifecycle, and about how to integrate now AI into that process. So this is a series of videos that I'm creating, which is aimed to give some context around this generative AI revolution for the essentially what I'm calling the working scientist, but this is the working researcher, major facility staff who are, may have played with these things, but not have thought very deeply or have some deep conceptual, underpinning about how these things work, how you can leverage them, why they might be useful in your research activities. So all of the videos are in our CI Compass AI Working Scientist GitHub organization and repository. They are all Jupyter notebooks, so you can click on them. This particular one is the context one, and all of the information that I'm talking about, you can directly click on and see. And if you look down below, there's a link to this repository, so you can go see all of the information and content and be able to go to do further resources. This is all in sort of support of a workshop that we're holding in January 2026, which is a AI meets CI intelligent cyber infrastructure for major and mid-scale facilities, aimed at sort of facilitating the conversation of how scientists, how facilities can leverage this generative AI revolution. Okay, so in the previous video, I introduced this idea of a foundation model and how they're trained, and I introduced some materials that I think are useful for everyone to sort of understand, particularly some videos made by Andre Karpathy. I suggest going and looking at that video and that material for a good context. So one of the things I'd like to sort of clarify and maybe extend is this idea of a context window. And that's what the subject of this video is going to be. And so in ChatGPT, which most people are familiar with, you end up with a dialogue, right? So you sit down in front of the computer and you start typing away, you hit enter, and then you get some response from the model. And so this is basically single-turn or multi-turn queries. It's what it's called. The context window is all those words that you sort of put into that dialogue, right? And so behind the scenes, there may be a system prompt, which basically gives some instructions to the model of how to behave during the conversation. So it may say, if you're building an application that's a customer support application, you may say you're a customer support agent, you're friendly. It may give some instructions about how to interact with the customer, and maybe some instructions on company policies or a few things that sort of set the tone for how the dialogue is meant to proceed. And then, so the idea is that then a user types in a message that goes to the network. The network spits out a set of text. That text goes back into the context window. So multi-turn is essentially all of those interactions between the model and the human being, all that text going back into essentially a buffer, right? Okay, so that was true up until roughly the beginning of 2025. And since the beginning of 2025, these models have become more sophisticated. And so they become, quote unquote, more agentic. We'll cover that in a future video about what that actually means. And we'll cover what tool use actually means in a future video. But for now, just think of it as these things can do more with the world of information. And they have connections to broader sense of information beyond what's just in the context window. And so they can go and retrieve information that may be useful for the dialogue. And so there's this really nice, this diagram that I'm actually showing you is actually from this Anthropic document that goes into a little bit of a deep dive about how to do this context engineering. And if you're really, interested in maybe building with these or interested in how these things work under the hood, it's well worth a read. It's written sort of at a technical but not deeply technical level, and I encourage it. But for our purposes, context engineering for agent means that there's an entire world of information that I can pull into the model. And that may be documents, that may be quote unquote tool calls. So this is basically functions that return information into the context window. There may be a memory file, which is essentially now all of these models, as you're interacting with them, they can do a reflection step, which I'll talk about in a second, and can then decide that this may be important information I should store for later. And it creates essentially this memory system where, sort of user preferences, things that you're interested in, all get stored into a quote unquote memory where the agent can later retrieve and more make the responses more personal in some sense, right? And so all of this information, right, you don't want to put in the context window at once. And so there's sort of this curation step where then the relevant information is put into the context window, or at least what the model thinks is the relevant information. And then that then gets fed into the neural network. And then the neural network either produces an output or it can call another tool, right? And so based off of the available tools that you handed it, it may actually say, oh, if I actually go talk to this database through this tool call, I will get more information, and that then will enhance my context, and then it sort of loops around, right? And so that's what this is what this is illustrating. So I think this is important to keep in mind that when you're interacting with these models, it's not just the dialogue anymore, but there's this entire set of processes that are sort of happening behind the scenes. So if you do Notebook LM or you do any of these new tools, they all have a sort of this component of essentially the dialogue that is dynamic, right? And so just as a reminder, these things are stateless, which I hope was sort of illustrated in that previous diagram, that the only thing the network knows is the current set of tokens that are going into it, and it predicts the next set of tokens that come out. And this one's in a loop until the dialogue is finished, right? Okay. And that one good way of maybe thinking about this is that Enric Karpathy in his video think of it as sort of a human being with this sort of short-term amnesia, right? So the human being doesn't remember past the few interactions with in the current conversation, right? And if it needs more information, it sort of has to write things down as it's going. And I don't know that this is necessarily a bad analogy. I think this is a good way of thinking about it, because it means that you have to remind the model, and it sort of dictates how you interact with it in some sense, to be able to get more useful interactions out of the model. These things are multimodal. So just as a reminder, these things can do not just text, but they can do images and voice now. And all of the major models out there are multimodal. And so when you put an image into the document, the quote unquote model is actually seeing the image, generally speaking. It's not always true, but the model has the capability of doing it. The different systems, the developers may or may not have enabled it. Okay. The other thing to sort of keep in mind, and this is related back to this performance context trade-off, right? That these these context windows started out fairly small, and the number of words that you could essentially fit into a conversation. But now they've grown quite large, where you can put, millions of words into the context window for a document. But they all still have, to some extent, this retrieval problem. And so, and this sort of matches how humans also remember things. Interestingly enough, although the mechanisms you should not infer anything from. And so when you start a dialogue, the important information that the model, or at least the information the model thinks is important, is usually at the beginning of the document and at the end of the document. And you tend to have very poor recall. So if you ask questions about a long document that you put in the context window, the stuff that's in the middle typically has much lower recall than the things that are at the beginning and the things that are last in the dialogue. Okay, what does this mean practically? So it means that generally when I start a dialogue with the LLM, I put important information about the context of the dialogue at the very beginning of the dialogue, right? And so I will create a summary of what it is that I'm trying to accomplish, what information you may need, what the purpose of the dialogue is, just to sort of set the context, because it will remember those sets of tokens, right? Now, if you're having a dialogue, it also means that in a conversation stream, the latest responses are actually going to be the more relevant responses to the next response that you get. And so if you're having a long conversation and you want to refer back to something that's in the middle, like that was maybe, 5 or 10 responses, above where you are in the chat, you may have to remind the model about that particular thing. And you may have to say, could you look back through your contest window and summarize what we've done here, or this particular point, and then use that as the basis for the next sort of round of interaction. That way, the model sort of gets refreshed, and you're now, instead of being in the middle of this where you have very, low accuracy, you're starting to get up into the regime where you have, some accuracy. Now, I'll say that the study was done, so this is all from this Lost in the Middle, how large language models use long context, if you're interested in sort of the deep dive of how this was done. And it's from 2024. So this was done actually in 2023, GPT 3.5. Models have gotten much better at this because everybody now knows it's a problem. They know it's a problem because they're trying to make very large context windows. And so there's a whole bunch of these, what they call haystack tests. And so the idea is that you train a model during its fine tuning or through other techniques of reinforcement learning to pay more attention to these middle tokens, right? And so the so-called haystack test is where you essentially embed an important, thing, maybe it's a number or something in the middle of the context, and then ask the model to retrieve it and how successful it is at that. And so you can use that as sort of, this sort of haystack method as a way of creating a fine tuning for the model that's more responsive, right? And so this is something that all of the frontier model, foundation model developers know about and are working on essentially improving. And the models are definitely getting better. But something you should be aware of as you're interacting with these. Okay, so there's sort of two more things I'd like to talk about related to the context. And the first is, if you watch the Carpathy video, which I hope you do, you talked a little bit about this DeepSeek R1 model, which is a open source model from earlier this year that does reinforcement learned chain of thought reasoning, right? And so I want to talk a little bit about where this comes from, right? And so it was discovered in 2022 that if you prompt the model as part of an interaction to think step by step, it actually would think step by step, right? And so it would start to output tokens that were the sort of first step of the process, the second step of a process, and in particular in terms of problems that you sort of have to reason through. And so these typically are mathematical problems, right? You're given sort of this puzzle that, that Roger has 5 tennis balls, buys 2 more, right? Each can has 3. How many does he have now, right? And so you do a set of these problems. You do reinforcement learning on this, right? So that the model tends to do more of this sort of chain of thought before it responds to you, right? And so this sort of discovery has now been incorporated into the structure of the models themselves. So the GPT 3.5 models, you sort of had to do this trick when you were asking it to solve a hard problem, to think step by step. Now, all this is done through internal thought tokens. And so they now have a little essentially a knob that usually the developer will have set for you, but it's the number of these internal thought tokens, like how many rounds of this internal step by step do you want the model to go through before it produces an answer, right? And so this is the so-called chain of thought. This is how models tend to reason through problems by using thought tokens. They've been reinforcement trained to think through the problem step by step, and then to do sort of reflection, and then maybe another round of chain of thought. And these are coupled together with a second pattern, which is called react. And so this is reflection and acting. And so this was another paper that came out in 2022, later in the year, that basically said, this quote unquote emergent capability of chain of thought, we can couple that with a sort of an OODA loop, right? What does it look like to do actions in the world, reflect on those actions based off observations, and then calibrate our react or do a reaction, calibrate our action to produce a particular goal, right? And this is sort of the fundamental sort of pattern that's part of these agentic loops, right? So how does a model know when to stop, right, when it's inside of a loop, right? And so this is typically how it works, right, is that React essentially has this feedback mechanism where the language model will do actions on an environment. It'll observe what those actions produced on the environment through the observations that gets fed back into the model. But then it does chain of thought reasoning traces that are also part of the loop that then refines the actions in order to produce an outcome. And so all of these models now have this sort of React pattern trained in to some extent, right? And so behind the scenes, the chain of thought, if you look at the GPT 5 models, which are the newest models, particularly if you put it into thinking mode, you can actually expand out all of the sort of chain of thought, and then you can also see how those patterns are implemented as part of the quote unquote agentic tools. So I think these are the basis for sort of understanding how these models take in information in the form of text, images, and audio, and produce some output which the human is interacting with. And so hopefully you find this useful. In the next set of videos, we'll talk a little bit more about what this idea of tool use is, and we'll talk a little bit more about how you put these things together I talked about in this video along with tool use to build a quote unquote agent, and what that actually means in terms of large language models. So thank you, and I hope that if you're part of a major facility, that you'll go to our website here and maybe register for the this workshop coming up in the January of 2026. So thank you.